Well, thank you very much. So let's start with the big question of the day. Why does the climate want privacy? Because it's changing. I swear, I looked for a long time for a climate change joke. That was the best one I could find. I know it's 8 a.m. I lived here for 4 years. I know how things go. OBGYN has a long and troubled history with environmental exposures and impacts on obstetric outcomes that are important, including preterm birth, low birth weight, and genetic conditions and anatomic deformities. This goes all the way back to kind of wartime biological warfare in Vietnam with Agent Orange that then has, in similar packaging been used for pesticides. We have medications like thalidomide that cause all kinds of limb abnormalities, and we have these environmental exposures that were kind of a cult for decades, like the heavy metal and mercury poisoning in Japan, in Minamata Bay, that caused birth defects and growth retardation. If you have ever been pregnant, or if you become pregnant someday and you're wondering, why are they always talking about fish and sushi, and why can't I eat all the fish that I want to? It's Minamata Bay. That's when we really discovered that the heavy metal kind of just sewage spill-off that is present in the ocean would eventually find its way through the biomass in the seafood and collect in pregnant women and cause defects. So this is nothing new in some ways, but we do have new challenges ahead of us. And of course, we all know about Flint, Michigan recently. The real tragedy of this, beyond all of the kind of obvious ones, is the long-term generational effects that it will have. And this is just in 2 years of data. The fertility has decreased 12%, and fetal death has increased 58%. One way to frame this lecture is to say what I'm not going to talk about. So I'm not going to talk about all the different ways that climate change, both related to air pollution and extreme temperature, can affect women's health in any possible category. That would include, by the way, this whole laundry list that's been published by John Balbus and others at the NIH about myocardial infarction, heart attack, pulmonary embolism, COPD, asthma. Across the entire lifespan, there are these effects, and they're so numerous they're too small to put on the screen. So I'm not going to talk about all those. I'm not going to talk about natural disasters. You might think we're here in New Orleans. I actually was here immediately post-Katrina as one of the first residency classes that dealt with the aftermath of that. And there have been studies, even systematic reviews, on the perinatal consequences of disaster responses and the effects on community that it has, including mental health impacts. Not going to cover that. I'm not going to talk about all the literature that the pediatricians have and their laundry list of the way that the vulnerable population of children are affected, including increased sensitivity to respiratory disease, food insecurity, water scarcity, the kind of mental health effects of refugees and changing your environment. Not covering that. Not even going to talk about all of the neurodevelopmental delay that is linked to endocrine disrupting chemicals, of which particulate matter, especially PM2.5, is one of them, and the large scientific consensus that has surrounded this list of chemicals that are here. It's called the Project Tender Consortium, that includes the combustion-related air pollutants. Not going to cover neurodevelopment, ADHD, autism. So at this point, you might be wondering, well, what is he going to talk about? Good question. We're going to talk about air pollution and extreme temperature and how it affects preterm birth and low birth weight. This is a scoping review that's different than systematic review. Systematic review typically will include pooled analysis of aggregated data. We do not do that. A scoping review is different than a simple literature search, though. It goes through and does an assessment of quality of evidence, and it has a very narrow focus for the scoping review. It can identify themes that are present within that literature. So this is a scoping review done by myself and a number of other authors, including the lead author, Bruce Bekar, who right now is in California with Climate Reality and their 24 hours coverage on their initiative. So you can tune into that if you're looking for things tonight. We did a keyword search for topics that are fairly obvious based on our outcomes and health impacts. There were 1,800 articles that were scanned. So just before we go even further, anytime someone says, well, there's really no literature out there about, do a literature search. You would be amazed what is actually out there that is just unknown. And I don't mean that as a slight to people who say there's nothing out there about it. It's hard to keep up with everything. But it is a, I think a professional obligation that we have to fact check ourselves frequently. So 1,800 articles if you just search for these key terms. Removing duplicates, looking at some key decisions we made. We're looking at US population only, the last 10 years only, and obstetric outcomes only. Doing all of that, scanning, we came down to 65 articles for full text review. Removing a few more that had OB outcomes that were parenthetical to what we were considering. So for example, chronic hypertension, gestational hypertension, preeclampsia were not our focus, but they were also in small amounts present. And there were some methodology questions we had about some of the studies, so removed 6 of those. We were left with 59 articles that were US population only, last 10 years only, air pollution, extreme temperature related to either low birth weight or preterm birth. There's also a subsection on stillbirth, which I've left out of this presentation, but it will be included in the final article. These 59 articles were level 1A to level 3 studies. 44 were cohort, which you might expect from a large population-based exposure. 7 were case crossover, 4 case control, 3 cross-sectional, and 1 meta-analysis. For air pollution and preterm birth, this table here does not represent all the studies. It would be very hard to show that on one slide for 24 studies. This is a sample, so if you want to take a picture and zoom in, you can see some of the effects we're talking about. But the high-level message was that there were 24 studies looking at air pollution linked to preterm birth, and 20 of them found a positive effect. 7 showed racial disparities. The range of the effect was from 2% increased risk of preterm birth to 21%. In a kind of more concerning sub-analysis, the risk for severe preterm birth, which is birth before 28 weeks, ranged from 46% to 183% increased by air pollution. And just to kind of clarify the language, preterm birth is anything before 37 weeks, severe preterm birth anything before 28 weeks. In additional subgroup analysis, there was a heightened risk for anybody who had asthma. And this is a representative study to give you a sample for what some of these 20 studies look like. So particulate matter exposure and preterm birth estimates in the US burden on both the health sector and the economy. These studies included multiple different types of air pollutants, but they all had PM 2.5. They determined that about 3% of the national preterm birth could be attributed to PM 2.5, and this created a $5 billion cost to the country, including $760 million on healthcare expenses. This map shows some regional variation. You can see very clearly there are some things you might expect based on economic and industrial activity. Down here, if you know where we are on the map of Louisiana, right by that bottom of the boot, it's one of the dark black areas. When we look at air pollution and low birth weight, we found 28 studies that looked at these exposure outcomes. 24 had an effect. 7 found racial disparities. The range for increased risk in low birth weight was 2 to 36%, and there was a heightened risk in this group if the exposure occurred 30 to 90 days before delivery. Here's a representative study from this cohort. They looked at, just by the way, let's see if I can find the number here. So the number included in this one was 222,000 mothers. So another thing that's often, I think, considered is, these studies, are they really large enough? Are they small studies? Do we have enough experience? This wasn't one of the larger ones, but it was not an outlier, really. There are 220,000 study patients, which by any definition is a large amount. 9% risk of low birth weight and 7% increased risk for very low birth weight. There are specific definitions for these also. They somewhat can depend on gestational age. I'm not going to get into the exact definitions, but I think it's fairly clear that low birth weight and very low birth weight are ranges on a spectrum of things we want to avoid. Looking at extreme temperature in preterm birth. We said extreme temperature because it does include the extreme ends, both the 95th percentile for high temperature, heat, as well as cold, but primarily we found heat was the exposure that was studied. There were 5 studies that looked at these linkages, and 4 found an effect. 2 of them also identified racial disparities. The risk for preterm birth ranged from 8.6 to 20%. And in this subgroup analysis, and again, there were numerous examples I could pull here. This was just kind of one of the more interesting themes. The risk was heightened during preconception exposure as well as pregnancy exposure. For sake of time, I'm not going to go into individual studies of these. I'll just lay out the extreme temperature and low birth weight data. There were 3 studies, all showed an effect. One of them identified a racial disparity, and here the risk for low birth weight was, in the one study, identified 13%. There's a relative risk of 2.5, and even when it didn't find low birth weight, it did find a reduction in weight for term deliveries. All right, great. Now what do we do? So there's all these kind of unavoidable ubiquitous exposures. There are perhaps some convincing data these are causing problems for our current pregnancies and the entire future generation. What do you do? Well, one thing is to understand, are these truly just associations? Is there any reason to think this might have actually some biological plausibility, and dare we even think the word cause in science? PM 2.5, I think the audience is familiar with, so I'm not going to go into it, but it is known to be biologically present and active at the placenta. The question is not so much as it crossed placenta or not, that has not been answered, although animal models suggest that it does. But it is biologically active at the placenta. And not to dive too deeply into the medical jargon here, but it does reduce the expression of at least 2 genes. These are, if you want to know, BDNF, brain-derived neurotrophic factor, and SNY1, which is synapsin. These are both involved in neurodevelopment. And so it gives us some biologic plausibility when we look at the neurodevelopmental delay that's identified with exposure to air pollution, both in ADHD and autism, that these genes that are involved in the neural signaling pathways are affected by PM 2.5 at the placenta. These are not known to be involved in preterm birth or low birth weight, but there are many other genes that have yet to be explored in this setting. Whenever we talk about a relationship being something besides an association, we also look at a dose effect. This study was not one that met criteria for the scope and review, but I thought it was interesting to mention here. This is a study from Pennsylvania, where fracking is common. They looked at 1.1 million births. So again, kind of the opposite of an anecdotal study. This is the definition of big data. And they found that not only was there increased risk, but there was essentially a dose-related response based on proximity to the fracking site. So infants that were born within 1 kilometer, 25% more likely to have low birth weight than those born more than 3 kilometers away. And they actually drew concentric rings of your risk, and it was, most dense in the 1 kilometer radius, and then within 3 kilometers less dense, and beyond that, the risk was not significantly different. So there does appear to be, at least in proximity, something of a dose response. But how about the big one? The knockout test. Right? One of the criteria is not just that an exposure and an outcome are associated, but if you remove the exposure, does the outcome change? And this is where I think we have good news. At least based on the experience in California, it does. This was a 10-year natural experiment in California where coal power plants were retired. And they looked at the preterm birth rate. This study had a paltry 60,000 patients involved. And they found a 20 to 25% reduction in the preterm birth rate over those 10 years. Now I can just tell you, when you see maybe 7% drops to 5%, that might not seem overwhelming, but when maternal fetal medicine doctors, the high-risk doctors, saw this data, they were astonished. They can't do anything that reduces preterm birth by 20%. The complexity of what causes preterm birth is not fully understood, and interventions to reduce this outcome are even less clear. So anything that comes in close to this is considered remarkable within the high-risk setting. So I'll close on what I hope is a sort of a happy note, that removing these exposures actually does produce a difference, and these are exposures that we have the power to remove. And with that, I'd like my information.